Today, we're going to be talking about innovation problem solving. And if I do my job right today, you'll hopefully leave with more questions than answers. Okay, so quick introduction about myself. My name is Andrew Ngui, and I'm the Director of Innovation at Startups at the Greater Peoria Economic Development Council. And what I really do is I work with startups and small businesses to help them overcome challenges to grow and scale their business. For those who aren't familiar with the Midwest, Peoria is the biggest small city between Chicago and St. Louis. And so coming back to the topic at hand, I am a thinker as well as a tinkerer. And so what that means really is that I ask a lot of questions all the time. I'm constantly thinking about stuff. And the reason why I ask a lot of questions is because, you know, the world around us is so unique and so exciting all at the same time. And, you know, you can look at the world through many lenses. And so that's one of the things I'm constantly questioning my surroundings. I'm also a designer in my first career. Some of the designs that I've created are used by millions of people daily. And one particular design, if you were earlier on in the chat with me, you would have kind of had a good laugh because that's gone around the world and has been even featured on Ellen. What else? I've recently started painting, so you can connect with me on Instagram. If you haven't tried art therapy, I highly recommend it. And so I want to move on. So this is a picture of Peoria. Here's where I am right now, and so I'm so happy to be here. Some of you may have heard this before. The questions you get depend really on the questions you ask. Thomas Kuhn was teaching at Harvard. Actually, he graduated from Harvard University and went on to teach at MIT. And I have had the opportunity to work at MIT for almost 4 years in the innovation space. That's how I know some of you that are attending today. That's really been a privilege of mine. And really, well, let's get into it. All right, first, solving problems well is about asking the right questions in a way that is efficient and effective, right? Asking the right questions is really about understanding if the questions that you ask are symptoms of something larger that you don't typically see, or are they root causes, right? And really the definition of a root cause is that it cannot be attributed to something else. And then moving on to the next part in terms of what do I mean by efficient and effective, it really means that there is an effort involved as well as a time duration component. So here, there are many approaches to solving problems: agile, lean, waterfall, much more. All of them explore the way to do it, but I've really not heard about any of them that address the factorial components of effort over time. And so let's get into that a little bit. Okay, so traditional problem solving gathers all the available information before the problem solving process begins, right? And you know, like the big issue here is what happens? Let's see. So the reason why I chose this background here is that the sun is rising over the earth, and I want to draw a parallel. Traditional problem solving takes a significantly long time. The Earth's orbit around the sun is 12 months, and there are really no observable effects because the distance of the Earth from the sun is so far. There's such a weak gravitational pull, and so similarly, in parallel with traditional problem solving, there is a long problem solving cycle. And typically it focuses on the entire process. There are significantly high barriers to engagement and ownership if you're taking the entire organization and trying to solve a problem, who actually owns the problem? Many departments, will think and say that they own the problem, but really at the end of the day, nobody really owns the problem. And in addition to that, there is a huge financial commitment. So these are significantly high barriers in getting people involved. And so, I want to pause for a second. If you have questions, you can please share them in the chat box, and Spencer can bring that to my attention. All right. How are we doing here? Let's see. Good? Mm-hmm. All right, we'll move on to the next part. Okay. Share again. All right, next page. By contrast, innovation problem solving, right? So innovation problem solving is about the efficiency of moving forward. It's about testing your assumptions quickly. So the contrast here is like the moon orbits the Earth. The moon goes around the Earth every 29 days. There is a strong gravitational pull and observable effects. And so what that means is that you can actually see that things are happening on Earth. The ebb and flow of the tides, the length of your days and nights, and also your seasons. And what this does is it actually parallels the process of innovation problem solving. That's a short problem cycle, of course. And a lot of times we start with just one part of the process and really low barriers, lowering the barriers for engagement and ownership, because really you're not asking the entire organization to come on board. We're asking only the few people who are in one small part of the organization to get involved. And low to zero financial commitment. Why? Because very often you can use parts or use resources that are already available to you. So really part of that is also a question of asset mapping and asset identification. What assets do you have and resources do you have to even make an experiment go? All right, so we're going to be going into our...
Sorry, Andrew, we do have one question from Bonnie.
Yes.
Would acquiring all data be necessary in certain industries?
Say again?
Would acquiring all data be necessary in certain industries?
It depends, right? So you can acquire a portion of the data, not all the data. And so it depends on regulations. It depends on the nature and scope of the work. I hope that answers your question. We can continue to follow up and discuss in a little bit. So we're going to start the breakout. Are you problem or solution focused? Why is that? How much information do you need before you're ready to start solving problems? And probably, Bonnie, that gets to part of the question that you were asking too. And what barriers have you encountered? And what have you managed? What have you done to manage those barriers? All right, welcome back, guys. Okay, who would like to share? Let's go.
I can go.
Okay, Abolaji, let's go.
Yeah, I think it's actually interesting talking with Spencer and Meenakshi to really hear how their approaches to solutions and problems. So, I mean, I, for example, I'm a problem-focused individual, so I tend to like look at the problems first before having to like delve into solutions I need to build. But then they have a mindset of having to look at the problems first, solutions first, and then creating a solution, and then going to find out like, hey, does anybody really need this solution that I've created? And then it's like, oh, bust the market, like, oh, somebody's already created a solution. So like sometimes finding out that you maybe wasted some time building a product that somebody already made, or even made a better version of. So I think having, I mean, the approaches kind of works differently, but then I think for me, it's more of, I think, having a solution, a problem mindset first before building a product. Definitely always win. My opinion.
Okay, I'll talk about our group. It seemed like I was with Jennifer and with Shivani, and both of them seem to be more in the like investigation fields, medical investigation and being coaches, and I'm in the cultural field. But it seems like the three of us, we had too many questions of how to deal with all the unanswered questions that this coronavirus is providing to us, and what's the best way to even answer questions with some of the people even ask us things. So if you're a coach, what do you answer? If I am supposed to tell people what to do, what do I say? So it seems like this coronavirus is really affecting us, and we're trying to see what everybody else is doing. And it seems like everybody seems to be in a very similar position where we are all very confused. That's kind of the wrap up. And yeah, we didn't have enough time to keep going deeper, but I hope I'm translating properly our brief conversation, Jennifer and Shivani.
So it sounds like what you're saying is that you feel like you are being tossed in the ocean like a boat, and you don't know where your bearings are, and you're kind of looking for your ground. Is that correct?
Yeah, in my case, yeah, I'm a little bit overwhelmed because I'm aware that what I was using before, I mean, in my very concrete case, I had a book tour with a whole thing, an idea. I was going to be present in many countries, and everything shut down. So now I have to find a new way. Everything I had before, it just doesn't work. And I guess Jennifer has many people asking her questions. There are new questions. Like they said before, there is no manual, although Trump says there is a manual, right? There is no manual, right? And we are all learning. I don't know if everybody feels kind of the same way. I speak for myself.
Absolutely.
And I was just going to chime in for our group and say we were getting the direction of going to also like think about what are our barriers. We seem to all sort of want to be solution oriented. And I thought Jennifer also brought up a great point that she's become more people oriented. Like instead of looking at problems or solutions, I hope I'm representing her view right. But I think she mentioned just like, she wants to be more people oriented. And maybe that is like right, like it's more holistic because problem solutions, it's all intertwined.
Yeah, that's so great. People focus, trying to figure out where you are in this whole big coronavirus pandemic. Thank you for sharing. We're going to move on to the next slide. I'm going to share my screen now. And surprise, surprise, most importantly, innovation problem solving leverages the natural laws of time and space. And what do I exactly mean by that? Really, it's about, if you look at the animated GIFs in the presentation, you'll see satellites that are leveraging the orbit of the planets to accelerate. And so it's the idea of, the more you get clarity with the problems that you want to solve, the more you're going to accelerate and learn as you continue to do that. And so, on a simple level, I think we've all seen the build, measure, learn loop. But what it doesn't specifically tell you, great, it's so simple, it's straightforward, yes, like it's a circle. But what it doesn't specifically provide insights to is the how to and why we're doing it. And of course, there are also a few other factors that I quite specifically want to get involved. And so the work that I've been doing in terms of iteration, it's not just about iteration. At the heart of it, you'll see it's a loop. But I want to extend the loop into a 3D space, and with the y-axis on effort and x-axis on time. And so when you start a problem, a huge problem that you want to solve, there's such a tremendous amount of effort that is required, you know, buy-in, and all the other parts of the getting people on board. And so there's a significant effort required for that. And also the time duration for that first loop that you're trying to build is quite long. But once you get going, you know, like a train, I think of the train when it starts going off, it's really, really slow. The wheels are turning really slow because the load is so heavy. But once you get going and you build up momentum, there's this idea, just like you see in the animated GIF over there, the moment the satellite loops around the Earth or the Moon or any of the other planets, there is this idea of a gravitational slingshot effect. And so I want to parallel that back to the innovation problem solving, or just problem solving as in and of itself, right? Like the first time you looked at a problem, you had assumptions. But as you continue to progress over the course of working on the problem, you either validate or you invalidate those assumptions. And those failures, what I call learnings, can be used to accelerate you on the next part of that iteration and the next part of the loop. And so the successes equally can also propel you in that direction. And so then you begin to see in the second loop, the frequency of time begins to shorten, which means that you're accelerating faster. And then by the time you continue to iterate over sequential loops, it gets faster and tighter because you're getting more success. You're honing in like a funnel through to the next part of the problem-solving journey. I want to check in here. Does that resonate with you? What are you thinking about? Over to you guys. Yes, question from Bonnie. Yes.
This is quite interesting. It reminds me of how even our mind, once we see an anticipation of a goal, and then we accomplish something, even at the smallest detail, and we accomplish that goal, our minds, our chemicals in our brains, like dopamine to be exact, gets triggered. So then you create this feedback, this loop cycle where you're continually going on to the next level, so to speak, iterating, because your mind is craving dopamine influxes. So it's interesting seeing it on this type of format.
Anyone else who would like to share their thoughts? Yes, Kurt.
Yeah, so it's interesting because, look, Minister Fuller said, you know, that pretty much everything in the universe is systems interacting. And what are the ways that systems interact? Well, one way is I orbit around a system, right? And when you're orbiting, why are you orbiting? It's because there's a force trying to pull you in, gravitation, right? But then there's this centripetal force, whatever, that's trying to make you fly away. And so then it's interesting because we orbit around ideas and groups and people, you know, so that's pretty cool. And then, but your point is that we can escape, right? And I wonder what the conditions for escape are. That's an interesting insight.
Great question. And so I want to go back to the slide here. If you just give me a second, share screen again, and then I'm going back to this share. So if you look at, let's say at this point, you're past the axis and then you're accelerating, you're at terminal velocity here at the red dot. And so what it's called is the, let me see here. I think it was called the Planetary Flyby. And so that's the moment when the engines of the satellite actually turn on to full blast and provide, as they swing around that axis and they're headed on, they're actually full blast on the engines so that they reach maximum velocity and then they slingshot back into the next, headed to the next trajectory waypoint. And so coming back to that, you know, like I said, the successes that we have validated as part of the assumptions, as well as the learnings or the failures, will be quite helpful in terms of determining next waypoint along the journey. Like you see here in the smaller animated GIF, it's not a straight line. It is a series of waypoints. But and Hema will know this because her husband's a pilot. But really, we're flying. When you're flying by waypoints. And yes, when you zoom out, it really looks like a straight line, but it really isn't. So similarly to that point, you know, it's the learnings and the successes where we get in each iteration that continues to propel us and shrinks that amount of time, because the next time I get into an experiment or assumption testing, that's where we're going to be validating the next set of variables, or, you know, disproving that they're actually appropriate as well. And so we're going to move into the next breakout session. How are you currently solving problems? Do you already factor time and effort in the process? What other factors do you also include in that process to improve the way you solve problems, and why? And do you also, and this is to Bonnie's point earlier, do you interchangeably use specific factors when addressing different types of problems in different circumstances? Everybody's coming back, so happy to have you back again. How was the second breakout room? Great. Okay, who would like to share this time?
It was great.
Okay, so can you share more about which part was great for you?
I'm sorry, guys, also that I have my video off. It's just better for the connection. I had it on earlier, but it wasn't working very well.
No worries.
But in our breakout room, it was really cool because we kind of engaged in the process to help one of the participants, Hema, as well. All three of us together, we realized it is about collaboration. And then Jennifer brought up the good point at the end, collaborating with people who are different from you as well. And we also discussed how sometimes, well, I was bringing up the point about how sometimes ideas sort of like come to me in dreams or meditating and walking, even if that sounds strange or cliche. And then Hema was like, yeah, no, it makes sense, because sometimes you're working, trying to force something and it's not going to happen, but you have to give it time to settle and things can click. So it's like this sort of magic too, like as much as we want to factor in time and effort, there's also some things that are a little bit effortless and don't take a lot of time when all the other engagement and work has been done already. I don't know.
Great point. Anyone else?
I'm just going to talk briefly as regards the factors, and I think a common factor that we all, my group kind of agreed to was the time, effort, and also the value of the time, and also how your time, apart from the value, is how time kind of gives that compensation, time, value, and effort. So also, and if you're kind of providing a solution to somebody and somebody's going to pay you for that time, like what kind of how do the person value your effort in terms of remuneration? Sure. Also, so I think that's a very, very important
great point.
Also, yeah, and then also to short time, apart from time, it's also the short time value, and there's also like the long term value of what the effort is.
Great points. Anyone else would like to share? Okay, Bishop.
Yeah, I think one of the common things that we discussed was that asking the right questions actually sets the foundation to problem solving, right? Like, even though I think Blair, Pierre, and I come from different industries, right? But the common factor there was if we are able to ask the right questions, it sets the foundation for problem solving. And what happened, especially Blair brought this point up, learning is a key factor. That if you're able to learn through the process, I think most of the problems find solutions. And yeah, I think pretty much that sums up our conversation. We didn't have enough time as usual.
Great. So what did we learn? Are you asking the right questions? Do the places where you study and work solve problems in a traditional or innovative way, and what can you do about it tomorrow, right? Well, today is Saturday. Okay, well, Monday. What are you going to do about it on Monday? And comparing and contrasting the orbits of the sun and moon and how that parallels in the challenges we face in problem solving, slow versus fast, and all the different factors in the components of going fast. What are those different factors? Leveraging effort and time as factors in the innovation problem solving process, but there are definitely other factors. And ultimately, what are you going to do differently from today onwards, and why? And so I have a bonus. We'll get to the poll in a little bit, but if you're okay, I want to get to the bonus component for a little bit, because the factor that I'm really talking about is behaviors. Why? Because we're human. We have routines, behaviors that we are ingrained in our lives. For example, we brush our teeth before we go to bed. We wake up and we brush our teeth again. And we have all these routines. And coming back to the original slide where I was talking about the initial curve, the tremendous amount of effort required to change the existing behavior. Like, for example, if you have to go to the doctor or the dentist in the morning, but you wake up and you're in automatic mode, your brain is in automatic mode, you might end up going to work and discovering, oh darn, I actually have to be at the doctor. And I've done that before, right? Like, or the way we drive, or the way we take our bus or transit, or whatever that might be. And unless you design for change to happen, nothing is going to happen. And so I want to introduce another small framework. It's called 3Bs, because there's literally 3Bs, to identify key behaviors that you want to change, because those are pivotal moments in your life, in your innovation journey, in the project. You want to identify those areas because those are pivotal. And what are the factors that are existing, right, in the project that you can start to lower those barriers? And in the direction that you want to design the solution to go towards with, how can you amplify the benefits? Thank you so much for your attendance today and for participating and for being a great audience for the workshop.